Today we're doing 11.7 dilations. This is the last lesson in chapter 11. Our I can statements today: I can identify dilations, I can dilate figures in the coordinate plane, and I can use more than one transformation to find images of figures. Okay, so for dilations, we're going to go ahead and skip through those. It says, tell whether the blue figure is a dilation of the red figure. Dilation means the size changes, but the shape is proportional. So the size isn't the same, but they're still similar figures. So from the blue to the red here, if you look at those are the same shape and they're different sizes. So that one is going to be yes. Same shape, different size. I'm going to go ahead and explain here. Because I believe on the next one they ask you to explain. B is no. It's actually a translation. They're the same size. Okay, go ahead and pause the video and try these next two. Okay, let's see if you are right. Number one is no, it's a reflection. They're the same size. And number two is yes. I'm going to write the blue shape is a larger, similar square. All right, so dilations in the coordinate plane. If we are dilating in the coordinate plane, they'll tell you where the point of dilation is. Point of dilation means where the points are getting larger by. So a lot of times when we're doing it in the coordinate plane, at least in this book and the ones we're looking at, origin will be our center of dilation. If we connect those corresponding sides, so the C's and the B's and the A's, those all connect at our center of dilation. When we want to know what my new points are going to be, we're going to multiply by whatever our scale factor is. Here they're calling the scale factor K. So when it's 2 times bigger, our scale factor is 2. When our scale factor is 1/2, then it's half the size. When you have a scale factor of greater than 1, the dilation is called an enlargement. It gets bigger. And then when the scale factor is greater than 0 and less than 1, so in between 0 and 1, then the dilation is a reduction. Your new one is going to be smaller. So let's take a look at this first problem. It says, draw the image of triangle ABC after a dilation with a scale factor of 3. Identify the type of dilation. Okay, so I'm going to start by just drawing triangle ABC. So A is at 1, 3. B is at 2, 3. And then C is at 2, 1. So here's my triangle. And then dilation is scale factor of 3. So I'm going to multiply my numbers by 3. So my copy of A is now going to be at 3, 9. My copy of B is now going to be at 6, 9. And my copy of C is now going to be at 6, 3. So I'm going to go ahead and put those onto my graph. So copy of A is at 3, 9. So over 3 up 9. Here it is. Copy of A. B is at 6, 9 over 6 up to 9. There's B. And then C is at 6, 3. Here we go. Okay. And then we connect. Okay. So hopefully you can see they're similar. I didn't do a great job of drawing that line very straight. But you can see they're the same shape, just different size. And if I connected those corresponding angles, the A's and the B's, they would all connect back to the origin. So that is going to be my picture. Now I need to identify the type of dilation. This one is an enlargement because my new one is bigger. And that happens because my scale factor is greater than 1. It's an enlargement. So for this next one, draw the image of rectangle WXYZ. They list the order pairs after a dilation with a scale factor of 5/10 or 1/2. Identify the type of dilation. So I'm going to do the same thing as I did on the last one. I'm going to start by drawing my original figure. So W was at -4, -6 over -4, now -6. Here's W. X is at -4, 8. So -4 up to +8. There's X. Y is at 4, 8. So there's Y. And then Z is at 4, -6. So 4, -6. Here's Z. All right. So I'm going to go ahead and connect these. All right. So now I'm going to go through, I'm going to multiply by 1/2. So I can do, say for W, I can do negative, oh, I don't want to write a 0 there. Right in the original 4. Okay. So I can do -4 and I can multiply times 1/2. And I can do -6 times 1/2. Okay. And times 1/2, remember, that's the same thing as divided by 2. So -4 divided by 2 is -2. This is going to be my copy of W. -2, and then -6 times 1/2, it's like -6 divided by 2. That's -2, 3. So I'm going to do the same thing on these other ones. I'm just going to write my order pairs next to it. So I'm dividing mine by 2. So for X, copy of X, it would be like -2, -4. Copy of Y is going to be at 2, 4. And then it looks like the copy of Z is going to be at 2, -3. All right, so I figured out where my new order pairs need to be. Now I just need to graph it. So copy of W, we said, would be at -2, -3. So here it is, copy of W. Copy of X is -2. Oh, that should actually be a +4 over here. Okay, so that should be -2, +4. So -2, +4, that's X. Y is +2, +4. And then Z is at 2, -3. Okay, and then I connect. You see if I connected my W's, connected my Z's, they would all go back to that center of dilation being at the origin, 0, 0. The type of enlargement, this one is a reduction. The second shape is smaller, and that's because I have a scale factor between 0 and 1. All right, so let's look at these next two. Okay, so what if triangle ABC in example 2 is dilated by a scale factor of 2? What are the coordinates of the image? And then for number 4, what if rectangle WXYZ in example 3 is dilated by a scale factor of 1/4? What are the coordinates of the image? Okay, so let's start with triangle ABC. Now it's a little hard. We'll have to flip back and forth just a little bit here. So ABC, let's see, 1, 3, 2, 3, 2, 1. Okay, so A, we had 1, 3. B, we had a 2, 3. C, we had at 2, 1. Let me double check that I did that right. 1, 3, 2, 3, 2, 1. Yes, I did. Okay. All right, so go ahead and pause the video. Try to find our new ordered pairs. Okay, let's check if your answers are right. So for all of these, we're doing a scale factor of 2, which means for each one, we're multiplying that value times 2. Now, I would like you to show your work for what you're doing. So there I am. I'm writing my points out. I've got my times 2's. Now I'm ready to write my new value. So copy of A is at 2, 6. Copy of B is 4, 6. Copy of C is 4, 2. So those are my new ordered pairs. All right, and then for the second one here, my scale factor is going to be 1/4. That's like dividing by 4. I need to flip back to see what my ordered pairs are here. So W was -4, -6. X was -4, 8. So let's see. W was -4, -8. X was at 4, was it 6? 4, 8. Oh, 4, negative 4, negative 6 was my W. Okay. So this one should have been a negative 6. And this one should be a negative 4, positive 8. Okay, and then let's see, for Y, we had 4, 8, and then 4, negative 6 for Z. And then Z, 4, negative 6. Okay, go ahead and pause the video, try this one. All right, let's see if your answers are right. So scale factor of 1/4 means we're dividing by 4. So for each one of these things, I'm going to divide my value by 4 to get my new ordered pairs for my dilation. Okay, so for my copy of W, negative 4 divided by 4, that's negative 1. Negative 6 divided by 4, that's negative 1.5. For my copy of X, looks like that would be at negative 1, 2. For my copy of Y, that would be at 1, 2. And for my copy of Z, that's going to be at 1, negative 1 and a half. I took each of my original ones and then I divided it by 4 since I have a scale factor of 1/4. I could have multiplied by 1/4. It would have done the same thing. All right, let's look at this next one. If vertices of a trapezoid are, and they list them, dilate the trapezoid with respect to the origin using a scale factor of 2. Then translate it 6 units right and 2 units up. What are the coordinates of the image? So here we're doing 2 different transformations to our shape. We're going to start with a dilation, and then we're going to translate it. Okay, so I think I will start by drawing my original shape. So A was at negative 2, negative 1. So that is A. B is at negative 1, positive 1. And C is at 0, 1. Okay. So there's my original triangle. Now I'm going to do my dilation. I'm going to use the scale factor of 2. I'm going to go ahead and just write my new numbers underneath here. We're multiplying by 2 to get them. So negative 4, negative 2 for my copy of A. Copy of B, I'm going to do negative 2, positive 2. Copy of C is going to be 0, 2. I did each of these by doing times 2 with our values to get my new ones. Okay, so now I'm going to go ahead and plot the points that I just wrote down. So copy of A was at negative 4, negative 2. So that's going to be there, copy of A. For copy of B, negative 2, 2. So negative 2, positive 2, that's going to be here. And then C is at 0, 2. That's going to be there. All right, so that's my new shape. Then I need to translate it 6 units right and 2 units up. So I'm going to count for each one. I'm going to count 6 units right, 2 units up. I'm going to switch colors here. I'll start with A. So a 6 units right, 1, 2, 3, 4, 5, 6, and then 2 units up, 1, 2. That takes me to 2, 0. This is my second copy of A. Make sure you put 2 apostrophes after it. Then I'm going to do the same thing with B. So 6 right, 1, 2, 3, 4, 5, 6, up 2. My new copy of B. And then C, same thing. I'm going to go 6 to the right, 2 up. My new copy of C would be right here. I'm going to connect them. And then I need to list, it asks me to list my new coordinates. So I'm going to look at my picture and write them out. So second copy of A is at 2, 0. Second copy of B is at 4, 4. And the second copy of C is at 6, 4. All right. So for our last type of problem here, we are identifying what the series of transformations is. So the red figure is similar to the blue figure. Describe a sequence of transformations in which the blue figure is the image of the red figure. So you can see a dilation is part of it because they're different sizes. And when it says the blue figure is the image, that means the blue figure is going to be the second one. Blue figure of the image, that means it's the second. That means our red figure is going to be our original one or our first one. Okay, so looking at our shape here, it looks like a rotation is a part of this as well. So if I'm looking at my shape here, it looks like there's a rotation. Remember, rotation, you need to have the amount of degrees, you need to have the direction, and you need to have the center point. So to me, if I look at it, it looks like the shape's going this way. So that would be a 90-degree, I'll add my 90-degree here, rotation. That's going to be clockwise about the origin. Okay, so if I did a 90-degree clockwise around the origin, I'm going to go ahead and just sketch in my new shape so then we can figure out what our dilation is. So here this original point was over 2, up 1, 2, 1. So once I rotate it, I'm actually going to be going over 1 and down 2. It's going to be right there. Am I right about that? Let me think for a minute. Yes. Okay. And then my next picture here, I've got 2, 2. So when I rotate it, that's going to be here, 2, 2. Okay. And then it looks like I am, so if I'm rotating, now looking at this, I'm going to go ahead and finish sketching my picture. But as I'm doing my rotation, this was 3, 3. Did I do that right? 3, 3, and then 4, 1, which would now be this. Okay, so I've done my sketch, but if you look at it, I've actually not, it's not pointing the right way. It's actually not a rotation that I need. Now that I'm looking at it, it looks like it's actually a reflection. And since I know a dilation is part of it, I do need to make sure I put that in. I could do the dilation first if I want to, but I'm going to do my other one first, my reflection. So it looks like, now that I'm looking at it a little bit closer, and sometimes, whoops, you do need to sketch it out and see where that shape actually is, and is it going where you want it to go. So if I'm reflecting across the x-axis, that's what that is there. So reflect across the x-axis. If I reflect it across, I'm going to go ahead and sketch in what that would look like here. Okay. So now that I've sketched it, I can see that it's in the same position as the other one. And it looks like from my order of pairs here, this is at this point right here. That point is at 2, -1. And then the corresponding angle is this one, and that's at 4, -2. So I'm going to have a dilation, and I'm multiplying by 2. So let's see, with a scale factor of 2. And then about the origin. It's always important with both rotations and dilations to mention that center of origin or center of rotation. So about the origin, center of dilation or center of rotation. Okay, always a good idea to sketch those out and make sure that it's turning out to be the way that you want it to be. Okay, so on this last one here, number 5, it says in example 4, use a scale factor of 3 in the dilation. Then rotate the figure 180 degrees around the image of vertex C. And then what are the coordinates of the image? Okay, so let's go ahead and go back to example 4 and then find vertex C. So here was my number 4. My original one for C was at 0, 1. So this was originally 0, 1. Now they didn't tell me I needed to draw it. So I'm just going to operate with it instead of actually sketching out the whole thing, because it didn't say to draw it. It just said what are the coordinates. So if I do a scale factor of 3, that means I need to multiply these numbers by 3. So my new dilated one would be 0, 3. And then 180 degrees, if I had a picture, so I guess I'll go ahead and sketch it just as a visual for you here. So, and I was putting it onto my graph. So here's my coordinate plane, 0, 3. So over 0, up 3 would be right here. If we rotate it 180 degrees, it becomes this new point, which I'll put on in red. So if I flip it 180 degrees, that's where it is. So my new coordinate there would be 0, -3. Now that I'm looking at it, though, it's not telling me that I'm rotating the figure 180 degrees around the origin. It's telling me that I'm rotating it 180 degrees around the vertex C. So I think for this one, it actually probably will be easiest if I finish my picture and then actually do my transformation. So I'm actually going to go back. I'm going to get all mine. So this was C. Let me go back and see what my A and my B was. So A was -2, -1, and B was -1, 1. Okay, so let's see. I had A was -2, -1, B was -1, 1, and then C was at 0, 1. I'm going to erase this one. The times 3s are still okay. So my new one, if I do my times 3s and my times 3s here, copy of A would be at -6, -3. Copy of B is going to be at -3, 3. Copy of C, that's the 0, 3. So all of that is fine, but the rotation of 180 degrees around vertex C, that is going to be easiest to see if we sketch it out. So I am going to just do a quick coordinate plane right here. Okay, so let's see. I'm going to go, everything's multiples of 3. So I'm going to go ahead and just go by 3s on my axis. 3, 6, 9, -3, -6, 3, 6, 9, -3, -6, -9. Okay, so I've got my coordinate plane here, A, -6, -3. So over -6, down -3. Here's where my point would be. I think I'm going to switch colors here and make it stand out a little bit better. All right, so there's my point. That is my copy of A. Okay, B is at -3, 3. So -3, +3. That would be my copy of B. My copy of C is at 0, 3. So over 0, up 3. Here's my copy of C. All right. So now that I have this, I need to rotate it 180 degrees around the image of vertex C. I'm not doing it around the origin. When I'm doing it around the origin, I'm spinning the whole thing. But here, I'm looking at how those points are relating to point C. So my new copy of C is actually going to stay at the same place, the second copy of C, because that's my center of origin, center of rotation. So that's not going to change. That's still going to be at 0, 3. But my B, now instead of being 3 units to the left, is now going to be 3 units to the right, because this is a 180 degree rotation. And then to get from point B down to point A, it looks like I have to go 3 to the left, and then I need to go 6 down. So now I'm doing the opposite of that. I'm going 3 to the right, and then I'm going 6 up, and then I'm making my points here. So there's my 180 degree rotation. Copy of B, second copy of A. Okay, so it looks like my second copy of A is at 6, 9, and my second copy of B is at 3, 3. All right, there you have it.